Hi, welcome to the AVM Math Hub. Today I'm discussing about some important problems for CSIR net. The topic linear algebra. Problem number 1. Consider the vector space Pn of real polynomials in X of degree less than or equals to n. Define the transformation T maps P2 to P3 by T of f of x is equal to integral 0 to x f of t dt plus f dash of t. Then the matrix representation of t with respect to the basis 1 comma x square and 1 comma x square comma x power 3. Here we are giving four options, four matrices. By using these four options, we have to solve this problem. Here 1 comma x square, it is a basis for domain space P2, and 1 comma x square x cube is a basis for codomain space P3. It is a basis 1 comma x square is a basis for domain space P2 and 1 comma x square x cube is the domain space for P3. We begin with the linear transformation. We begin with the given linear transformation. Given T of f of x is equal to integral 0 to x f of t dt plus f dash of t. We first find the image of basis vector domain with respect to t. Image of the basis vector domain with respect to t. First base vector 1 and the next base vector x and the next base vector x square, like this. First we have to the base vector 1, that is f of x is equal to 1, then f dash of x is equal to 0. Now the transformation with respect to the basis 1 is equal to integral 0 to x t into dt plus 0. F dash of x is equal to 0. That gives integral t means integral t into dt, that is equal to 1 into dt. So here 1 in f of x means 1 into dt, that is equal to t limits 0 to x, that is equal to x minus 0, that is equal to x. Now we can represent it. This can be written as the linear combination of basis vector of codomain space. So only x terms that can be represented in the coefficient 0 plus 1 into x, that is x power of 1, that is 1 into x plus no x square coefficient, that is equal to 0 into x square plus 0 into x cube. This can be written as the linear combination of basis vector of the codomain space. Therefore, the coordinates with respect to the codomain space is t of 1, that is equal to, see, first one is 0, x coefficient to 1, x square coefficient 0, and x cube coefficient to 0. So 0 1 0 0 0 1 0 0. So this is the representation. And next we have to find the base vector x square, base vector 2, that is x 1, base vector 2 means x, base vector 2, that is x. So let f of x is equal to x, then f dash of x is equal to 1. So image of the, therefore the image t of x, that is equal to integral 0 to x t into dt plus 1, that is equal to integral t means t square by 2 upper limit and the lower limit 0 to x plus 1, that is equal to x square by 2 plus 1. So this is the x square coefficient and constant is there. That is, this can be represented the linear combination of basis vector of the codomain space. So that is equal to the coefficient is there 1 plus no 0 x coefficient. So 0 into x plus x square coefficient means 1 by 2 into x square, and no x cube coefficient, that is equal to 0 into x cube. Therefore, the coordinates of the vector t of x, that is equal to 1 0 1 by 2 0. And the next base vector 3, base vector 3, that is equal to f of x is equal to x square. Then f dash of x is equal to derivative means 2x. Therefore, t of x square is equal to integral 0 to x t square dt plus 2x, that is equal to t cube by 3 limits 0 to x plus 2x, that is equal to x cube by 3 plus 2x. So this can be represented in the linear combination of basis vector, the basis vector of codomain space. So 0 plus x coefficient 2 into x, x squared, no x square. So x square plus 1 by 3 into x cube. Therefore, t of x square is equal to the matrix 0, 2, 0, 1 by 3. Therefore, we construct the matrix associated with the linear transformation. We construct the matrix associated with the linear transformation, that is equal to t of 1 comma t of x comma t of x square, that is equal to the coordinates of the image with respect to the coordinate space of the columns. So we can write in the columns t of 1 means 0 1 0 0 0 1 0 0, and the next matrix 0 1 0 sorry 1 0 half 0, and the next 0 2 0 1 by 3. So finally, this is the coordinates of the image of coordinates of images with respect to coordinate space of the columns. So 0 1 0 0. So we can check in the options. So fourth option is the right answer. And next, some important concept and important definitions on algebraic multiplicity and geometric multiplicity. Already we know the algebraic multiplicity. The algebraic multiplicity of an eigenvalue lambda is a number of occurrence of lambda as a root of characteristic polynomial. So once again, the algebraic multiplicity of an eigenvalue lambda is a number of occurrence in how many times that number will come. A number of occurrence of lambda as a root of characteristic polynomial. For example, we have to find the roots of the characteristic equation. Suppose we get lambda is equal to 2, 2, 2, 3. So the the number of occurrence of lambda is 2. Why? Because the 2 is repeated in number of times. So the number of occurrence of lambda as the root of characteristic polynomial. And the next definition, geometric multiplicity. The geometric multiplicity of an eigenvalue lambda is the number of independent eigenvector. Independent means only single value. Independent eigenvector associated with an eigenvalue lambda. So that is the definition of geometric multiplicity, and some important results. Eigenvalues of upper or lower triangular matrix or diagonal values. So diagonal values means this is the diagonal values. Upper value means 0, like this. This is the upper triangular matrix. So whenever we'll get the upper and the lower triangular matrix, these diagonal elements or the eigenvalues of upper and lower triangular matrix are diagonal values. Whatever values are presented in the diagonal elements, that is the eigenvalues of the given upper and lower triangular matrix. And the second point, if the algebraic and the geometric multiplicity of each eigenvalues are equal, if the algebraic and geometric multiplicity of each eigenvalues are equal, then it is the diagonalizable matrix. And the third point, geometric multiplicity is always less than or equals to algebraic multiplicity. And the next point, if algebraic multiplicity is 1, then geometric multiplicity is also 1. This is a very, very important point. AM means algebraic multiplicity, GM means geometric multiplicity. If a matrix has a distinct eigenvalues, then it is a diagonalizable matrix. This is also a very, very important point. If a matrix has distinct eigenvalues, then it is a diagonalizable matrix. By using these conditions, we solve this problem. One important problem, that is, see, which of the following matrices not diagonalizable? Option A, 2, 0, 1, 0, 3, 0, and 0, 0, 2. Option B, 1, 1, 1, 1. And option C, 2, 1, 0, 0, 3, 0, 0, 0, 3. Option D, 1, minus 1, 2, 4. So by using the definitions, algebraic multiplicity and geometric multiplicity, suppose we take option 1, that is, take option 1. Let capital A is equal to 2, 0, 1, 0, 3, 0, 0, 0, 2. Why? Because we can take the options 1, which of the following matrices are not diagonalizable. So there is no equation and there is no another options are there. So that's why we can use the options. By using options, we have to solve the given matrices diagonalizable or not diagonalizable. Let us say, let capital A is equal to 2, 0, 1, 0, 3, 0, and 0, 0, 2. This is the upper triangular matrix. Therefore, the eigenvalues of upper triangular matrix are, therefore, eigenvalues are, so this is the upper triangular matrix. Upper triangular matrix is, in upper triangular matrix, the diagonal elements are the eigenvalues. So 2, 2, 3. 2, 2, 3. The eigenvalues of the upper triangular matrix capital A is 2, 2, 3. Now, the algebraic multiplicity of lambda is 2. Therefore, algebraic multiplicity of lambda is equal to 2. Why? Because 2 is repeated number of times. 2 is repeated number of times. And the algebraic multiplicity of 3 is only 1, because 3 will appear only one time. And an algebraic multiplicity of 3 is 1. 3 is 1. So we don't have any problem with the algebraic multiplicity is 1. Now we can calculate the eigenvector associated with 2. Now we can calculate the eigenvector associated with 2. So for this, we have to write the algebra equation, the characteristic equation, into x is equal to 0. That implies lambda means 2. We can subtract this capital A means the given matrix 2, 0, 1, 0, 3, 0, 0, 0, 0, 2 minus lambda. Lambda means 2. We get A minus lambda means 2. I into x is equal to 0. That implies A means capital A means 2. 2 minus 2, 0. and we get 0, 0, 1, 0, 1, 0, and 0, 0, 0. Understood? So 2 minus 2, 0 minus 2 minus 2, 0, and 1, 0, 3 minus 2, 0, 0, 0, 2 minus 2, 0. So, and x, y, z, x, y, z, that is equal to 0, 0, 0. We can write the equations of the given matrix. Ax is equal to b, 0 into x plus 0 into y plus 1 into z. So z is equal to 1. Therefore, z is equal to 1. And similarly, 0 into x plus 1 into y plus 0 into z. So 1 into y plus 0 into z. So we get y is equal to 1. So, and x belongs to our, we are not getting any value for x. So that is we can assume that that value is a real number. So any real number. That is equal to x is equal to, we are not getting value, so we can write x that is equal to this can be written as x into 1 0 0 0. That implies the vector v is equal to 1 0 0. So we get only one vector, only one eigenvector associated with the eigenvector 2. So we are getting only one eigenvector associated with the 2. Therefore, algebraic multiplicity of lambda is equal to 2 is 2, and the geometric multiplicity of lambda is equal to 2 is 1. So these two are not equal. Therefore, algebraic multiplicity is not equals to geometric multiplicity. So it is not diagonalizable. It is not diagonalizable. So, and suppose it is diagonalizable, we can take another matrix. Suppose option 2, we can take option 2. Let capital A is equal to 1 1 1 1 1 1 1. So we to find the eigenvalues, now we write the characteristic equation that is equal to that a minus lambda I, that is equal to 0. That implies 1 minus lambda and 1, only diagonal elements 1 and 1 minus lambda. So 1 minus lambda 1 1 1 minus lambda is equal to 0. After calculating 1 minus lambda AD minus BC, 1 minus lambda minus 1 is equal to 0. That implies 1 into 1 minus 2 lambda plus lambda square, and minus 1 is equal to 0. And lambda square minus 2 lambda is equal to 0. Take common lambda, and the lambda minus 2 is equal to 0. That implies lambda is equal to 0 comma 2. Okay, so lambda minus 2 is equal to 0, then lambda is equal to 2. So we get two eigenvalues, that is equal to 0 comma 2. So these two are distinct eigenvalues. Already we see here the note points, and the algebraic geometric each other values distinct. Fifth point, if a matrix has distinct eigenvalues, then it is a diagonalizable matrix. So it is a diagonalizable matrix. So it is a diagonalizable matrix. Similarly, suppose it is not a diagonalizable matrix, so we can take option 3. That is a check whether it is a diagonalizable or not diagonalizable. Then after we can go to the fourth option similarly. Okay. Right. And the next problem, what is the rank of the following matrix? So this is the 5 by 5 matrix. In 5 by 5 matrix, rank of A means the number of non-zero rows. The number of non-zero rows. The rank of a matrix is the number of non-zero rows in row echelon form. So option A 2, option B 3, option C 4, option D 5. So this is the given matrix. So we can write the given matrix, and first we have to find the row echelon form. Row echelon form means upper triangular matrix, or this can be 0, it will be 0 0 0 0 0. So this is the procedure of row echelon form. So now first we have to change row 5 r5 minus r4, that it will be 0 0 0 0, and r4 is tends to r4 minus r3, so we get this matrix, and r3 tends to r3, tends r3 minus r2, so we get this row, and r2 tends to r2 minus r1, so we get this one. So this is in the form of row echelon form. Here we observe that the number of non-zero rows is equal non-zero, 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 non-zero. All are non-zero rows. Therefore, the number of non-zero rows is equal to 5. Therefore, rank of A is equal to 5. So this is the way we have to solve any problem by using the given options, uh, or the given function, a function, and given options. We have to solve any problem. Okay. Please learn carefully. If you have any doubts in these problems, please message me, or please leave a message. I will give the a brief clarification about these problems. Thank you so much. Have a nice day.